Hello, this is the AB 2006 question 2, and we're looking at another rate question. This is a single rate question, and here we're looking specifically at cars turning left, and this equation is a rate. We are also given the graph of L of t. I'm just going to write that down below, and in knowing that this is a rate, that means we're probably going to have to do some stuff involving figuring out a total accumulated amount using integration, or maybe interpreting like a thing like cars per hour, because they like doing that too. Let's look at part A. So we're given this equation. By the way, this is calculator active. So in terms of what we're doing as far as showing work here, that's going to be a different standard of what you need to show for the calculus. So in terms of this, we're going to find the total number of cars turning left at the intersection over the time from 0 to 18 hours. Okay, so if we have an equation that gives us a rate for cars turning left, the total is going to be equal to the integral from 0 to 18 of L of t dt. And hopefully you have plugged in your equation into y1, and then you can just deal with this in terms of substituting a y variable into your equation pretty easily. When you do this, we should get a value that's equal to 1,658 in terms of your total cars that are there. Cool. All right, next up, traffic engineers are going to consider restrictions when L of t is greater than 150 cars per hour. Okay, find all values for which L of t is greater than 150. Just visually, this is not actually going to help me in terms of finding the numbers here, but I can see that there are going to be two values. And I'm going to graph the function L of t and set y1 equal to that. I like that I can write real well. Y2 I'm going to set equal to 150 and find those intersections. I find that the first one is going to be at 12.4283, and that my second one is going to be at 16.1216. All right, I don't love those things, so one of the tricks that I can do for the AP test is to call things letters so I don't have to write things out as much. The less likely that I can make a transcription error by accidentally copying a number down wrong, the happier I'm going to be for this. Okay, so we've got to find all values. We did that. We got to compute the average value. Average value. Okay, I know what that is. That's my integral from a to b, and I actually use those letters. That's kind of cool. That was not intentional. Of our function L of t, and we want over the interval from b to a. So we're dividing the total accumulation here by the width of that interval. And when we do that, we should get 199.426-ish. And by ish, I mean 0.426. I want to make it really clear that's a 199. There we go. And in terms of this, the thing that we have to be careful of is make sure that we show what we're doing and that we get the answer here. In terms of your calculator, you can do this part right on there, which is why we don't have to show any work. Also, many of the antiderivatives that you'd have to do here are not doable with the amount of knowledge that you currently have or will have at any time in the mathematical future. For part C, So we're looking at traffic engineers will install a signal if there's a 2-hour time interval during which the product of the total number of cars turning left and the total number of oncoming cars traveling straight through the intersection is greater than 200,000. In every 2-hour interval, the 500 oncoming cars travel straight through the intersection. Does this intersection require a traffic signal? Explain the reasoning that leads to your conclusion. Okay. So in terms of this process here, we've got something that we're given this weird equation here, which is the product of the total cars going left, so that's like L of t, and 500 oncoming cars is equal to 200,000. So when I am dividing here, we get dividing this by 500. 2 of those go away, 2 of those go away, and 2,000 divided by 5 is going to be 400. So if it ever goes above this for 2 hours, this is what we're looking at. If I am taking a look at what's going on here, and I actually just really noticed something super important. This would be saying the rate is 400, and that doesn't really make sense. So let's think back to what this originally said. Total number of cars turning left. That's what we've been doing this whole problem. So instead of this rate, I really want the total number, which is going to be from, I don't know, any A to any B. We have a 2-hour interval going on there. So that means that the accumulation over this time would be a total of 400. So try to find somewhere that the area under this curve would be equal to 400. I'm going to look maybe at as high a peak of this as I can get, so that I've got the maximum value that I can. I don't know, is that 14? No, I guess not, but whatever. I'll start at 14. I'll go to 16, and by the way, this could be done on your calculator very quickly with any 2-hour interval. And in terms of finding out this area, the magic is going to happen is if we are greater than 400, then this 2-hour interval works for us. It doesn't really matter which one we choose, but if I choose, I don't know, 14 to 16, and do that calculation, I end up with a number that we can then use to see if this works or not. This is not the only way to do this, but this is a way to do this. And because I got 412.265, we must use a traffic light. And the reason that we need that is because if we have the 412 and then the multiplying that by the 500 gives us more than that 200,000. I guess a clearer way to express that might be to talk about these being greater than instead of equals in terms of figuring out where those points are. Solving them is the same process anyway. And if we have something that's greater than 400, we are good. So as a whole here, we had to process the idea that we were given a rate instead of a function of some kind of a quantity. And then we had to deal with a lot of FTC stuff as far as understanding what that rate meant. in terms of points here. For the first one, we get 1 for the setup, 1 for the answer. In the second one, we're looking at that interval. Cool. The average value of that interval. And then finally, we need an answer with units. I don't remember if I actually wrote the units on that. I'm thinking that I did not. For the other one, we need some kind of... there are 2 different ways to look at this. So let's look at each of these pieces. That we looked at 400 cars. Cool. That we considered an interval h and h plus 2. We looked at 14 to 16. Oh, they looked at 13 to 15. We got like 412. They got 431. So we're okay with that. An answer with some kind of explanation. In terms of the other way to look at this, these are the values that were always above 200. And since that is more than 2 hours on its own, that puts us in good shape anyway.